Hello, this is Insei with InMoov for Choreonoid. This is a technical update video, so there's going to be lots of technical jargon. And if you're not into that, you can just watch the regular update video. But if you are, then stick with me, strap on your seatbelt, and let's do this. Alright, so to get started, I'm going to go straight to the code. So the main things we're going to be looking at are this translation.python script, rotation Python script, and the bodylink C++ file, as well as an InMoov body file and Choreonoid itself. Right. So inside of Choreonoid, there's what's called a bodylink view, which comes with Choreonoid, and you can open up views by going to View, Show View, and you can see bodylink from the drop down. Unfortunately, the original bodylink view does not allow you to edit body files. So body files, if you looked at the other videos, you might recall, are what specifies the translations, rotations, masses, inertias, etc. of this model, like you're seeing here on the screen. So we want to switch back to that body file. Okay, there we go. So this is InMoov.body. Right now we have 37 parts, and you can see, like here, you have the name of the part, the parent of the part, so what the part, the translations and rotations are relative to. The translations, the rotations, joint ID, joint type, etc., center of mass, and most importantly the geometry. So those are the STLs directly from InMoov.fr. Now, to get the bodylink view to actually write those changes to that body file, I'm using the Python scripts, and I'm accessing them using what's called the system command from inside of C++. So you can see that here on line 863 and on line 888 I call it system, and I pass in my argument. So the argument is going to be Python, my script, the model file that we're working with, so InMoov.body, and then you pass in either XYZ translations or XYZ, or sorry, roll, pitch, yaw rotations. And then we can look into translation.py. So we can see here the usage. You type in translation.py, specify a model file, specify your link name, set X translation, Y translation, and Z translation. And we also have those values brought in here, X, Y, Z, in the from the sys arguments. So system, abbreviated as sys, is what allows you to pull in the argument you type in. So the third argument we type in is, sorry, the fourth argument we type in index, at index 3, because we are computer scientists, so we start counting at 0. Anyway, so at index 3, or position 4, is the X translation. So you have sys args v at position at index 3, which is your fourth argument here, and so on, the fifth argument and the sixth argument for Y and Z. Then I just print out X, Y, and Z for debugging information. I also have this original translation function, which just reads the file and gives me the original translation values once again for debugging. And here I open the file on line 20, read all the lines, store that information into a variable called lines, close the file, and then open the file back up. Just have to change the parameter so that we're going to be writing to the file instead of reading from the file. Set a couple condition variables, and then search for the link name. So I find a name like this, and then also if that line contains the link name that you passed in as an argument. So that's your the argument at index 2, so your third argument. Then it will tell the program, yes, we found the link. So link found, then it gets set to true. Once you find the link, then you want to look for wherever we're doing the translation. Once we find that, then we want to print the original translation, and then we want to write the new translation, the X, Y, and Z that we specified up here, and set updated to true, and then we write all that information to the file. Same thing with rotation.py. This code is considerably more complex, but that has to do with the mathematics of the rotation, which I really won't get into. But if you're interested in that, you can look up Euler angle to axis angle format conversion, and vice versa. Axis angle to Euler angle axis angle to Euler angle format conversion. So that's a fun read. I'm still trying to wrap my mind around certain things. There's this thing called quaternions, which I'm still getting the hang of. So I won't go into details about the mathematics, but this code works similarly with yaw, pitch, and roll. So then, with these new additions to bodylink view.cpp, we then go to the terminal, go to Choreonoid. So I'm going to close this session of Choreonoid. Then we're going to rebuild Choreonoid. So make -j 4, and I've already built it before, but once you make those changes inside of Choreonoid, this file is located under source/body plugin/bodylink view.cpp. So you go to that directory, and then once you make those changes, you have to rebuild. And once you rebuild, then you can run Choreonoid again. So then I'm going to open up Choreonoid by doing /bin/Choreonoid, and then open up Choreonoid with our project. So add a directory up, // then InMoov 442 scripts InMoov.cnoid. So now you see the project loaded, and it's loaded with the model file. And just like in the update video, I'm going to show you that you can change the translation of different parts. So I'm going to set this translation a little bit lower to 200. Hit Control R to see the updated change. You can also set yaw, pitch, and roll. But the issue with yaw, pitch, and roll is that the value returned for roll, pitch, and yaw isn't actually the same as the value input, so that gets really confusing. So the value returned right now isn't always accurate, but there are only 3 values you have to remember, so it's not too bad. And another point that I forgot to mention, you have to click on what part you want to make the change to, because that's how the program tells the name of the part and how it differentiates between each of the parts. Otherwise, how would you know what part you're trying to translate or rotate? So that's defined by clicking on the part here in the links view, and you can see the values are updating in the body link view. But that's basically it. Thanks.